first part of this unit was on permutations. The second part of this unit is on combinations. Sometimes we want to order things. That's what permutations was about, putting things in order. Sometimes the order doesn't matter. Okay, so you get to choose 3 books from 4 books for your English class, and it says from the library here. You have to read all 3. Well, if you choose books 1, 2, and 3, and you go, no, I'm going to change my mind, I'm going to read books 3, 2, and 1, you're like, those are the same 3 books. The order doesn't matter here. You're still winning those 3 books, right? Or if there was a contest and you won, and as winning, you got to pick 2 prizes from the prize table. And there's like 10 really good prizes, like TVs, bicycles, new cars, like everything you can imagine. It's a good contest. So you like pick the new car and the brand new TV, and then you go, wait a minute, I'm changing my mind. I'm going to take the brand new TV and the new car instead. And someone would look at you and say, that's exactly the same. You still have the same 2 things. The order didn't matter there. Okay? We're going to now do questions like that. We've done questions where order matters, and now we're going to do questions where order doesn't matter. And that adds a complexity, because now every problem-solving question you get, you'll have to read it and you have to decide, is this a question where the order matters? Is it a permutation question? Or is it a question where the order doesn't matter? Well, if the order mattered, right, books 1, 2, and 3, they would all show up with the same as all 6 of those different things, right? 3 things, 3 choices, 2 choices, 1, you get 6 different ones. If you chose 1, 2, and 4, that's the same as all of these. We already know from permutations that if you had 3 spaces and you started with a 4, you would get 24. What a combination does is it says, we're going to count permutations, but take the order out. How many ways can you order 3 things? 3, 2, 1, or 3 factorial? 6 ways. So if you take all the permutations and divide out the order, because every permutation has 6 orders, you will get the number of combinations. And so our combinations formula is just our permutations formula with the order divided out. And this is on your next page. But unlike, you know how we hardly ever used our permutations formula because we could just do spaces and it was a lot easier? We will use the combinations formula a lot because it's really easy to use. It looks complicated, but when we do it with some numbers, you'll see some patterns which makes it really easy to remember and figure out. So let's start by this. It's on your formula sheet as well, and we can go to example 1. Certain lotteries, the order doesn't matter. Have you heard of the Keno lottery? No. Have you heard of, like, what's the main lottery, like Lotto 649 in Canada? Have you heard of that? We'll do that one right after. It's really quite fascinating. But this one, if the order doesn't matter, and sometimes they tell you how many combinations, so they're telling you the order doesn't matter, we're going to use the combinations formula. And sometimes I use the word choose, because if you're choosing things, the order doesn't matter because you're collecting them all. We have 80 numbers, we need to choose 20 of them. And what makes the combination formula easy, here I'll write it out because the formula itself doesn't look easy. But the n, which is this number, is going to be on the top as 80 factorial. The r is going to be on the bottom and the two numbers on the bottom will always add up to the one on the top. So it's really easy to remember because you're going to have your 80 factorial on the top, 20 factorial on the bottom. You're like, well, what would add up to 80 on the bottom would be 60. And we're going to have to find our combinations button on our calculator, which is in the same place as your factorial. It's the third one there. So I can go 80, choose 20. It's a huge number. 3.5 times 10 to the 18. Which is interesting because if you try to do it little bit by little bit, it's actually quite interesting that if you just tried to do 80 factorial to start off with, the number's so big that your calculator shuts down. So I can't do 80 factorial on its own because it's too big. But if I put it into the formula, the calculator is smart to cancel out certain things. And the answer was huge. So let's do something that you're maybe more. Does Lotto have two T's for Lotto 649? Yes? Don't they write it like little 49 underneath, like something fancy like that? So the Lotto 649 is based on the idea that there are 49 numbers and you have to pick 6 of them. And the order doesn't matter. Sometimes they have like this big thing like balls in a barrel and the one number comes out, then a second number comes out. It doesn't matter what order you pick the numbers in. If you pick all 6 numbers, you win the huge prize. Okay? So what that means is we can calculate what are your chances of winning. Because this is good to know. Should you play or should you not play? Does anybody know how much it costs to play now? I don't play. Because I've done the math and I know I'm not going to win, most likely. But we'll look at that. We can actually plan. I've got a plan to win. I haven't ever done it, but it would guarantee it would work. We'll look at that. You want to win the lottery? You can do it. It's just going to be expensive. Okay? But Lotto 649, 49 choose 6, so we would have, and we'll go to our calculator. I mean, according to the formula, the bottom number would have 6. What other number would be down here? What adds up to 49? 43. So that's what the formula would tell us. We go to our calculator. We go 49, choose 6, 13,983,816. $916? Is that right? That's the number I said? 806. Oh, what's this? Good. Perfect. Okay. Just under 14 million. Okay? That is not a very good chance. Right? If I had a deck of cards, where's the deck? And I got you to pick one. And I said the number. Like, ready? Ace of spades. No. Right? But if I did it, you'd be like, whoa! Mind blown. You'd be like, that's amazing. 1 in 52 chances I have to get this right. And you would have been amazed. Okay? Now imagine I have a deck of cards with 14 million cards. And you pick one of them. Right? And they're all numbered from 1 to 14 million. And I'm like, 3,852? And you're like, no. It was 132,851. How hard would it be to guess that? Almost extremely unlikely. That being said, if you want to win the lottery, we just figured out how to do it. Right? Let's say our ticket's $2 or $5 now. I don't know, because I don't. Let's say $2. Right? Not worry about inflation right now. Okay? So if the prize is $50 million. Okay? If you guess all the numbers right, you win $50 million. should just go to the bank and say, I would like to borrow $28 million, please. And they'd be like, oh. And then they say, why? And you say, I want to win the lottery. What do you think the chances are that they're going to give you $28 million? Zero. But if the prize is $50 million, wouldn't that be a great idea? You could buy every single number. You'd have to start, like, it might take you a long time to fill out all the cards. But you could buy every single number, and as a result, guarantee that you would win the lottery. What could be a problem? Right? You go to the bank, you get the $28 million, you convince the junior associated bank that they believe that they should give you $28 million and that this is a good idea, and you fill out all the ones, and the lottery comes through, and you have to find it. It's in your 14 million tickets. There's one of them's a winner. You just have to find the right one, and you win. What could possibly go wrong? Nothing. What if someone else wins? Then what happens? You split it. So 50 million split into 20. So, oh shoot, I borrowed 28 million. And now I have to split the winnings with somebody else. And I go to the bank and like, oh, we won. But I'm $3 million short. I hope that's okay. Do you think that'll be okay with the bank? Oh yeah, probably, right? However, so I watched a guy on YouTube. He was looking at actually Great Britain's lottery. They have Lotto 659. They just changed it to 59 instead of 49, which makes the number way bigger and your chances of winning way worse. However, they added a thing that if you got 2 numbers right, you got a free ticket for next time. Right? And he said, what you're actually getting with the lottery, when you buy the lottery, you should not hope to win. Because, right? Just like when I picked one card out, you're like, haha, of course you're not going to get it right. If you think about 13 million cards, and I randomly picked the number, right? We could do it right now. I could write down a number from 1 to 13 million, and whoever gets it gets 100% on the next test. But you won't get it. Because it's so hard, right? I could probably even do it with the cards and be really risky. But the problem and the idea in math is, why does somebody win then? Well, if I did it with the cards, you have a 1 in 52 chance of guessing it. So mathematically, that says if you tried 52 times, not guaranteed, but chances are 1 out of 52 says if you play something 52 times, 1 out of those 52 times, you would guess it right. And you'd be super amazed, right? What happens with the lottery? As the prize gets bigger and bigger, 50 million, do more or less people buy tickets? More people buy tickets. You ever hear of that Powerball in the US? They had like a $3 billion prize, something insane. People from Canada, you could only buy tickets in the United States. Actually, this is stupid, mathematically stupid. Flew down to the United States, spent hundreds of dollars on an airline ticket to buy tickets to a lottery, and the chances are like even worse, like really, really bad. But when enough people buy, you eventually have that chance that someone could get it right. And if they don't get it right, the prize just increases the next week. Yeah. So here is the idea of why playing the lottery might be worth it, according to this guy on YouTube, is if that $2 bet lets you have the greatest daydream for a day of like, what if I won? What would I do? And that daydream brings you so much happiness, then that $2 was worth it, because you're going to lose right? But I found that in life, you don't have to spend money to daydream. So like, you can, like, I used to daydream about finding treasure. Be like, I'm walking, I'd walk to university and be like, maybe I find treasure. And I'd be like, okay, this is a little bit unrealistic. It's not like pirates are going to leave treasure in Winnipeg that I would find. But then I'd be like, ooh, maybe there's like some drug lord drives by and they're getting chased by cops, and so they throw a suitcase out the window because they don't, and I just happen to find the cash, right? So I daydream about this, but I'm like, okay, I've never heard of that really happening. So I lower my expectations as I walk, and I'm like, till the point where like, maybe I just find a quarter on the ground and it has happened. I found money, but the one day, my daydreams were coming down. I started with the treasure, and then I went to the drug lords throwing me cash. This happened. And I'm walking, I'm like, well, maybe I just find like a gift card. And I took 2 more steps, and on the ground was a $20 gift card. I was like, this is, when I was in university a long time ago, have you ever heard of the store HMV? No. Or some, that used to be like a music store, but apparently everybody just buys music online now. So places to buy CDs and DVDs and stuff like that, they don't exist anymore. But I did get, and I remember the album that I bought. I still have that album, still enjoy it. Very good. So if you like the daydream, you can pay the $2, but a hint, you can daydream for free. Just not during math class, then I get math, right? But any other time, you can imagine winning loads and loads of money and how exciting that would be. You can daydream about finding the winning lottery ticket instead of spending your money on it. But now you know your chances, and they're not very good. Okay, questions for practice on this one? 4, 5, and 7. Oh, that whole daydream's on video.